Welcome to Fission 101. Food science isn't just about following a recipe. It's about understanding chemical transformations. Today, we're comparing the structural chemistry of baking against the biological chemistry of fermentation. We're going to break down exactly why these foods behave the way they do using 5 key scientific concepts. First, let's look at texture. Why are cakes light and fluffy while cookies are dense and chewy? The answer lies in lipid saturation. Cakes use liquid oils, which are unsaturated fats. Why does this matter? Chemically, these molecules contain double bonds that create kinks in the carbon chain. These kinks prevent the molecules from stacking tightly, keeping the fat liquid and the cake texture airy. Cookies use butter, a saturated fat. Its molecular chains are straight and stack perfectly, staying solid at room temperature. This provides the heavy structural support needed for a chewy cookie. But those fats need a structure to hold on to. That brings us to gluten formation. Wheat flour contains 2 proteins, Gliadin and Glutenin. Watch what happens when I add water. Why is this sticky? The water allows these 2 proteins to unravel and bond together, forming a stretchy, elastic network called gluten. In baking, this network traps gas bubbles. In cookies, we want a strong network to hold the shape. In cakes, we mix gently to keep this network loose and tender. Now, let's switch to fermentation. Unlike baking, which relies on heat, this relies on microbes. The key concept here is anaerobic fermentation. Why is the jar sealed? Because this metabolic process requires the absence of oxygen. By cutting off the air supply, we create an environment where only beneficial bacteria can thrive. They convert carbohydrates into lactic acid, which effectively pickles and preserves the food from the inside out. In alcohol fermentation, like in beer, yeast produces ethanol. But chemically, what gives alcohol its unique properties? It's the functional group. To illustrate, this chain is ethane. It's just a gas. But if we swap a hydrogen for a hydroxyl group, right here, it completely transforms the molecule. Why? Because this oxygen-hydrogen bond adds polarity. This specific group turns the gas into a liquid, makes it soluble in water, and provides the distinct aroma and bite found in fermented beverages. Finally, safety. How do we prevent food from rotting? We manipulate water activity. Bacteria need free, available water molecules to survive. In fermentation, we use salt. Why does salt work? The salt acts like a chemical magnet. It bonds tightly to the water molecules, making them unavailable to microbes. This lowers the water activity to a level where harmful pathogens dehydrate and die, while our salt-tolerant fermentation bacteria survive. Thanks for watching.